We're going.
All right, this is 12-5, and actually we're going to throw in 12-6 also. So we'll call this a double header lesson, 12-5-6 combo. We're going to start out on page 798, and we're going to have Mary read the theorem from 12-6, or 12, what is that, 12-16, while I put it up here. Go ahead, Mary.
An equation of a circle with the center hk is a radius, and the radius r is k minus h squared plus y minus k squared equals the radius squared.
So that would be a good thing to have on a note card, and I'd like to explain what it means. It means that if you have a graph of a circle, HK stands for the center of the circle. H is the x coordinate, the K is the y coordinate, and the R is the radius. So if you've had a circle right here, R is how far out the circle goes from the point HK. And the best way to demonstrate how this formula works, I think, is just to start right on our assignment. So go ahead and flip to page 801, and Jackson's going to zoom in on that number 1 there while Mary reads it. I mean number 8. Sorry.
Number
8.
With the standard equation of each circle, the center is 2, -8, and the radius is 9.
She says we got a circle at 2, -8. And the radius is 9, so if this is down at -8, I feel like that circle would go all the way up to about here. So we have a circle about this big, and we have to write an equation for it. This is the plan that we will use. So for answer number 8, you don't really need the picture. I'm just doing it for a visual aid here. So your answer for number 8 will go like this: X. And then, Nathan, what is the X of the center?
2.
So we got to go X minus 2 then. This is just following the standard equation for a circle. Then it's going to be Y. Nathan, what is the Y of the center?
-8.
So we got to go Y minus a -8. Do you see it's going to be backwards? You see it's going to be like this. So they're always going to be backwards. A -2 means the center is at +2. A +8 means the center is at -8. They're always going to be backwards. I'm sorry, it's just the way it works. And then right here, we have to put R squared. They told us the R is 9. Well, this isn't hard. We're done. We're done.
That's it? No algebra?
Not yet.
Ah.
So that's how number 8 would work. Why don't we do a number 17 there? Focus in on that, Jackson. And we have to write an equation for 17 and pan over to the picture of it there too, Jackson, on that 17. And I'm going to use my David Burns back there. David, this isn't very complicated so far, so I'm pretty sure you're all over it. What should I put right here? The X. He's correct. I need to put the X. Actually, I need to put the opposite of the X. Are you looking at that little graph there?
Yeah.
What is the X there of that center spot?
-4.
So-
4.
All right. All right. Audience agreeing with him?
Uh-huh.
The audience agrees with you, Dave, so I'm going to let you do another one. What is the Y of that center spot?
-2.
-2, so I should put,
No. Negative. It's +2.
it is, the center's at +2, so I should put -2?
Yeah.
All right, just gotta know what you're thinking here. Can you see what the radius of that circle is about on that graph? Is it possible to see the radius?
Yes.
What is it?
It's 4.
All right, kid's got a keen eye. He noticed the blocks are worth 2 on this graph. Focus in on that. The blocks are clearly worth 2 apiece, so the radius is 4. So then, Dave, I should put here, Dave,
16.
these aren't so bad, are they?
Not yet.
That was like impossible.
Well, let's jump to number 19 where they try to switch the game up a bit. Going now to number 19. Leave some space. We're going to do a number 19 now. For 19, I will use the assistance of Riley. Riley, in number 19, do we know the x of the center?
Yeah, it's at .2 or -2.
So should I
That's
write down
plus
+2?
2. Yes.
Because they're always wrong backward, you know. And what's the y of the center, Riley?
That's 6, so it's y -6.
Well said. Now this time they didn't flat give us the radius. And we don't have a picture. Do we have,
Radius is 4.
how did you figure the radius is 4?
The center point on y, or the central point is -2,6. And the point that the circle has to go through is -2,10.
So it's just like
Y is
4
just
down,
4
kind of?
higher than what the central point is.
So what are you suggesting I put right here?
16.
Yeah, that wasn't so bad either, was it, Jackson?
No, it wasn't.
All right, let's try 21. Notice on 21, they are not giving us a center that's exactly across or above the other point. We need somebody with a nice loud voice like Isaac. Isaac, take a look at that 21 there. What is the x of the center?
Well, you would have to put down x minus 7 because it's a positive 7.
Well said. Clearly communicated there. How about the y?
Be y plus 2.
Alright, that part of the game seems to be totally mastered here. Is it immediately obvious what the radius is of this circle?
No,
What do we have to go on?
a graph. Oh, yeah, distance formula.
Alright, so we have 2 points. We know where the center is. Apparently the center is at 7, -2. And where is this point?
1, -6.
You said distance formula?
Yes.
So with the distance formula, we could figure out that, which would be the radius?
Yes.
Alright, does anybody want to help with this? We've got Mason. Pan over to Mason over there. Mason, what are you suggesting for how would you do this?
Well, first, I would find my note card that has a distance formula on it,
Okay.
which is the square root of x2 minus x1 squared plus y2 minus y1 squared,
Yeah.
and I would plug those numbers in to the equation and solve it. Or you can do it like that.
Alright, so he's saying you would go minus, you would just find the difference between the 2 y's and square it, difference between the 2 x's and square it, and he would end up with a 6 and a 4, I think, that he would have to square. Wouldn't that be a 36 and a 16 then? And then you'd be doing the square root of that? So I'm going to go 36 plus 16, 52. Why did I put that right there? Don't we have to do the square root yet?
No, because it's squared.
Radius squared.
Yeah, here's what I was thinking. We gotta do the square root to find the radius, then we gotta put the radius squared there, and that's like kind of undoing what you did, so I just put 52 right there right away. Square root of 52 squared is 52. I think that's all the help we're gonna need with that lesson. I think part A of the double header has been kicked. Let's turn the page.
I'm gonna end it. Start a new one.
Yeah, we're on 12-6 now. And to teach 12-6, I'm going straight to the lesson actual. I'm on 808 already.
Wow.
808. Okay. Jackson will focus in on number 1 on 808, while Mary reads the instructions above and number 1.
What is a sketch and description for each focus of point on a plane? Points 4 centimeters from a point X.
She popped out a new word. It's the word of the day, locus. Locus is just a set of all the locations. All the locations put together. What does it make? So I have to have a point X. That's my point X. And we need to have the locus of points 4 centimeters from that. Well, I think 4 centimeters up would be about here. 4 centimeters down is about here. 4 centimeters left is about here. 4 centimeters right is about here. Are there other spots 4 centimeters from X?
Yeah, it is.
Like there,
Yeah.
and there. So, Dave Burns, if you had to describe all of them, what shape would it make?
Square.
That's
Circle.
our name. The kid is so blame funny we can hardly take it. All right, set of all locations is a circle. We have to even say more if we can, because there's a lot of circles in this world, and they're in a lot of places. So we should say circle with radius 4 centimeters, and I know this seems laborious, center at X. That describes the locus of all locations 4 centimeters from point X. Let's do another one, see if we're getting the hang of this. And I'm going to fire David. Good. Yeah. And I'm going to go to, whoa, Jackson. Can you film and talk at the same time?
Possibly.
Awesome. Okay, we're looking at number 2. It says all the points 2 inches from UV. That'd be segment UV, it looks like. So I'm drawing for you, or help here, Jackson. Segment UV. And we got to think of spots 2 inches from that. Well, there's one. And there's one. And there's lots of them. If I thought of all of them and put them all in, what would I have?
Rectangle.
Thinking
Circle.
Are you thinking this spot is also 2 inches from the segment?
I'd say so.
All right, I'll put him in. This one?
Mm-hmm.
He's 2 inches from the segment?
No.
We better move in a little, right?
Yeah.
How about here? That's too far, isn't
Too
it?
far.
It's gotta be like in there. What are you now thinking, all of the shapes, all of the spots?
How about an oval?
Oh man, I'm writing that down, kids. gifted, the great gifted Jackson Olson. That'd be an oval that is 4 inches wide. Right? Thinking 4-inch wide oval?
Uh-huh.
How many inches long? There's no way.
You
I've
can't
never
tell
told you how
because
long that-
yeah.
You can't really know, right? But maybe you could say 4 inches longer than UV. Could probably say that. So you get the idea? When they ask for locus, you're putting down all possible locations, what would that make? All possible locations, what would that make? That's what locus means. The word of the day. Let's jump to number 5. Number 5 is where we try to use our communication skills. Riley's going to try to tell us the difference between the word locus and location, or how they're related.
The locus is the location of all the points around a certain figure, if it's the circle or the segment.
I think he's on this. So the locus is the group of all the locations. Oh, I need somebody who can think 3D. Are you able to see beyond just flatness, Isaac?
Yes.
All right, Isaac is going to be the 3D man. And we got the points J and K here, Isaac. Here's point J. Here's point K. And first of all, in the first half of number 6, is thinking about points equidistant from JK, J and K in a plane, which would mean like on the board. Is this spot equidistant from J and K?
Yes.
Do you see another one?
Yeah.
Like maybe that one?
Yep.
Maybe this one? There's a lot of them. If you had to describe the locus, which is all of them, what would it be?
A line.
Nice, the kid does see things, but this is still 2D. He says the locus of all the points in a plane equidistant from J and K is a line. But now, I've asked him to bump it up into another world. Now he's going to have to think 3D. Isaac, do you see some other points in space that are equidistant from J and K?
Yes.
Like this one,
Yeah.
this one,
Yep.
this one,
Yep.
and what if you saw them all? What would you have?
Cylinder. Circle.
Riley sees 3D, a plane. So this is a line in space. It'll be a plane. And that plane will go way exactly between there. Your assignment for tomorrow is 12-5 and 12-6, a double header.
What
Can we
number
do
is
the
that
work
up there with
three?
12-5?
Let's sign off before they complain too much and make